Okay, so this is, we've looked at what you know, and now we're going to see what's in store for you. So just to define this, so we are all working with a standard definition. You guys had lots of good pieces of it, but a chemical reaction is a process, and it's a process where you have a change in one or more substances, and you create new and different substances. Important points here. These terms, and I think you all know these from physical science, we will not dwell on them, products and reactants. If we have A plus B yields AB, these are the reactants. This is the product. So the reactants are what go in, they're what do the reacting, the products are what are produced. They're what you end up with. And that last point, total mass of reactants must equal total mass of products. So a number of years ago, I took a really unpleasant chemistry test. It's called the Praxis exam. It's a 2-hour chemistry test, far and beyond what I had done in terms of chemistry in many, many years. It was part of my licensure program, and you weren't allowed to have a calculator. And there was a problem there was a stoichiometry problem on there. And it was like, okay, if this mass of magnesium oxide and this mass of zinc chloride reacts, and these products are formed, what's the total mass of the products? And I'm sitting there going, oh my God, okay. And I'm like trying to figure things out, and I'm adding up columns of numbers. Duh. The mass of these has to equal the mass of these. Duh. Doesn't matter what these and these are. The mass you start with is the mass you end with, because you can't make up atoms, and you can't disappear atoms. So you're just trading dance partners. You're just moving them around. You're rearranging them. Whatever mass of reactants you begin with, that's got to equal the mass of your products. And we'll do lots of that kind of work. Okay. So here's our pretty dove gray background. Whoops. That's not the right side. Okay. So this chapter is about chemical reactions, but to describe them, we're going to use chemical equations. And they're not the same thing. An equation is the way that we talk about a reaction. So the reaction is the process that's occurring. The equation is what we record on paper and can share with somebody else to describe that process. What a chemical equation does is it represents the chemicals that are the reactants and the products using symbols and formulas. You are all good at writing formulas by now. If you're not, and you need to still take your naming quiz, you should do that soon. It shows you the identities, the states, and the relative amounts. So the one piece of this that is new to you is the state information. And if you look at this, you'll see little tiny subscripted letters down there in parentheses. And that tells you what physical state each of the reactants and products is in. And this equation can be read just like a sentence. And by the time, I would say by Tuesday of next week, you will be able to look at a sentence like this, and you'll be able to write an equation from it. That's one of our goals. I haven't gotten the learning goals printed yet for this unit, but that's one of your first ones, is write correct chemical equations when given information about reactions. So I'll give you a sentence, and you will write an equation. So if we were to read this chemical equation, we would say, solid ammonium dichromate reacts to form gaseous nitrogen, solid chromium 3 oxide, and gaseous water. Now, if we wanted to read that with even more detail, we could say 1 mole of solid ammonium dichromate reacts to form 1 mole of gaseous nitrogen, 1 mole of solid chromium 3 oxide, and 4 moles of gaseous water. Okay, so you're reading it just as it's text. All right, this one, based on what you told me, we don't have to spend a whole lot of time on. because you know a lot of this from physical science. So we're just going to kind of refresh and review. What tells you that a chemical reaction has happened? The first one is everybody's favorite, heat and light. Kaboom! We don't do a whole lot of kabooms in here. We don't do any kabooms if we can help it. But we do a reaction in Chapter 11, Stoichiometry of Gases, that gives off a lot of heat. We do a couple reactions where things will heat up. We try not to, like I said, we try not to do anything that is a rapid evolution of heat and light. That would be a kaboom. So things heating up, things lighting up, those are good indications. The production of a gas. How do you know if a gas is being produced? Tiny bubbles. Bubbles, bubbles, bubbles. Bubbles indicate the production of a gas. So when suddenly the stuff in your beaker starts to bubble, there is an insoluble gas that wasn't there before, that is now, and it's bubbling up out. The classic example of this, how many of you have played with vinegar and baking soda? How many of you have played with vinegar and baking soda? Okay, I was going to say, if you haven't, you have homework tonight. Go home and play with vinegar and baking soda, for Pete's sakes. Jeez. So yeah, production of a gas is often a sign that a reaction is taking place. And when we mix the acid and base of vinegar and baking soda, that's what those bubbles are telling us. Formation of a precipitate, you saw this in your last lab. You made a lot of different kinds of precipitates. Remember, a precipitate is when you have a nice clear solution and suddenly you get chunks in it, or it gets cloudy. Because if you are not part of the solution, you are the precipitate. Yes. And a color change. That's a fairly obvious one. If something changes colors, it's because you have a new substance that's a different color than the old substance. So what was the iodine, or what was the indicator with iodine? When you added something to iodine, it turned what? Turned like, yeah, dark, dark, dark blue, purple, black, depending on the concentrations. You've created a new substance that's very dark in color. So that's indication that a chemical reaction has taken place. Okay, this is where we'll start tomorrow because this is where the other class left off. But just when we talk about chemical equations, these are the biggies for them, the three biggies. Have to represent known facts. You have to have correct formulas, and you are all pretty good at it so far. And a few of you are going to polish it up and be perfect soon. And obviously you can't create atoms and you can't magic them out of existence. So, okay, we'll pick it up tomorrow. If you haven't printed off notes yet, I would suggest that you do that tonight. You're welcome to do it here, and we'll